Hey folks, Mr. Dell here. We are looking at a problem that has fractions in equations. And so I'm going to use fraction busters to show you how to solve this, how to make these um, equations nicer to solve, to come up with what is the x that makes them true. So I'm taking this problem from CPM Course 3, and this is Chapter 5, Closure. Specifically number 5-68. So it says solve each equation. So the first one here, x plus 1 over 3 equals x plus 2 all over 5, right? So I can play the game of just plugging in numbers until I finally find the number that makes this true. You know, does 2, does 1, does 6, does, just keep plugging in 1x and trying to come up with the right answer. But sometimes the answer is an integer value, and it's a fraction or something similar, and it could take forever to figure that out. So I'm going to show you. Let's just take this and use fraction busters. So remember, a fraction buster, just so you know, a fraction buster is the common denominator. Running out. There we go. Is the common denominator, right? So the fraction buster is the common denominator. Those are the same thing. So if I look at my denominators, 3 and 5, what is the common denominator? Well, what does 3 and 5 both go into? What's the common multiple? Well, it would be 15, 3 times 5. So what that means, I'm going to take and multiply 15 times each of these fractions. So this is one big fraction, x plus 1 over 3, and I'm multiplying by 15. On the other side, the same thing, x plus 2 over 5, I'm going to multiply by 15. I'm just multiplying both sides by 15 in this case because there's really just two fractions on each side. So when you multiply, remember, when you multiply by a fraction buster, you put that fraction over 1. And anytime you're multiplying fractions, the denominator and numerator of each fraction can cross simplify, right? So the 3 goes into 15 5 times, and that 3 becomes a 1. It's like simplifying 15 over 3 is 5 over 1. So why did I do that? Because when I now multiply this side here, I'm taking 5 and I'm multiplying it times the x plus 1. So what I have now is just 5x plus 5. I've got to, remember, don't forget, I got to distribute that 5 gets multiplied through. And so then over here, the same thing will happen. Put the 15 over 1, and the 5 and the 15 can cancel. The 5 becomes a 1, the 15 becomes a 3, right? Because 5 goes into 15 3 times. And once again, I'm multiplying, so I got to multiply, and I have to distribute. Anytime I'm multiplying times a binomial or more than one term, each term gets multiplied. So this becomes 3x plus 6. So now I have an equation without fractions. So I can go ahead and just use my same rules of solving equations. Okay. In this case, I'm getting all my variable terms on one side, so I'm going to subtract 3x from both sides to make that go away. And I get 2x plus 5 equals 6. Then I'm going to subtract my constants, get all my constants on one side because I'm trying to isolate that variable term. And I get 2x is equal to 1. And then divide both sides by 2. And there we have it. X is equal to 1/2. So there's my answer for this question. Yeah, that would have took me a long time to try to guess that and get that number. So having this method of fraction busters makes it nicer to be able to get to the answer. So I'll show you this one here. So again, fraction busters, right? My fraction buster is my common denominator. I have a 3, a 4, and a 2 as my denominators. What's the common multiple? What does 3, 4, and 2 all go into, right? If I can take 3 times 4 and I get 12, all right, does 2 go into 12? It does. So I'm going to use 12. So that means I'm going to multiply 12 times x over 3 plus 12 times x over 4 plus 12 times 1 equals 12 times x over 2. So I multiply each of the terms, right? Each of the terms on both sides of the equation by whatever that fraction buster is. So, and when you do, again, you can look at it as cross cancel. I'm going to show you something else too. You can look at it as cross cancel, or if you were just thinking about multiplying straight across, this becomes 12x over 3, right? 12 times x is 12x. 1 times 3 is 3. But then you can see, oh, well, 12 divided by 3 is 4x. So either way you look at it, because I could have done the cross reduce first. 3 goes into 12 4 times, and the 3 becomes a 1, right? If I simplify diagonally, it would have been, I would have got my 4x right away, because 4 times x is 4x, and the 1s on the bottom are not necessary anymore. So there's different ways of looking at whether you're going to cross reduce or just multiply straight across. So again, I'll put the 12 over 1 because I'm multiplying fractions. And I'll show you this one, 12x over 4, right? 12 times x, 1 times 4. And if 12 does divide by 4 3 times, so that becomes 3x. And I still have this plus in between. And then plus, there's no fractions here. It's just 12. 12 times 1 equals, and then this one I'll do the cross reduce. 12 and 2. 2 becomes 1. 12 becomes 6, right? You actually diagonally simplify. So now I have, when I had that 12 was over 1 before I did that. So you saw it was a fraction times a fraction. And then 6 times x is just 6x. So here's my nice equation with no fractions. So on this side, I still have to simplify, though I have combining like terms to do. I get 7x plus 12 is equal to 6x. Get all my variables on one side. That means I've already just got my 6x, my one variable term over here. So I'll get rid of the variable term on this side to get them on this side here. So then we have 12 is equal to negative 1x. Then divide both sides by negative 1. So x is equal to negative 12. And there's our answer. Okay.